All right, guys, I am so sorry about my internet earlier today. I just wanted to do these problems for you so that you would have a better idea of what free fall is actually talking about. All right, so number one under today's lesson is a rock falls from rest. All right, so right there, very important. That's going to mean that the initial velocity is going to be equal to 0 meters per second. Okay, so if it says it takes 2.5 seconds, that's going to be time for the rock to hit the water. How high? That's going to be distance. Distance in these formulas is the x. All right, so t equals 2.5 seconds, and we want to know x. Well, in anything that's going up and down, dropped, thrown up, anything like that, we always have gravity. And that's going to be your A, your acceleration. Acceleration due to gravity is going to be negative 9.8 meters per second squared. All right, so looking at all of this information, I'm solving for x. These are the only formulas that we have to look from, and this is the only one with x in it. So I have to choose this formula. Now, I'm going to also tell you, remember how we said that VI is going to be 0? Well, XI is also going to be 0. So I can get rid of that whole first section. If XI is 0 and VI is 0, anything times 0 is going to be 0. So I'm just going to cancel all that out. So my formula this formula, I can cancel that part and cancel that part because all of that is 0. So now it looks a lot simpler. If I just do it like that, I'm solving for x. A is going to be the negative 9.8. T is 2.5 seconds, and that is squared. So when I put that in my calculator, I can do 0.5 for 1/2, negative 9.8. 2.5 all squared is equal to negative 30.6. So because it's asking how high, that's not going to be a negative, that's going to be a positive. So x is going to equal 30.6 meters. That's going to be your answer. Now it wants to say, it says, what is the velocity of the rock when it hits the water? So we want to know the final velocity. So now this one we have is 30.6 meters. So looking at all this information, I'm going to choose this formula right here. VF equals VI plus AT. VI again is 0, so that makes it good for us because we can cancel some stuff out in our formula. All right, so there's your formula that you're going to use. VF is what you want to know. That's 0. A is, whoops, negative 9.8. That was a 9. Negative 9.8. And T is 2.5 seconds. All right, so when I multiply those two together, you get a negative 24.5. So VF equals negative 24.5 meters per second. Because the rock is being dropped, it's going down, and down is negative. So that's okay. And then it says, what is the speed? Well, we found the velocity. My dog in the background, sorry. We found the velocity of negative 24.5 meters per second. Well, speed is the scalar quantity. So if the velocity is negative 24.5, the speed is just going to be 24.5 meters per second. Same thing, just without that direction. All right. Number 2, a ball falls from rest. All right, very good. We like when it starts from rest because that says that the initial velocity, give myself some space here, the initial velocity is going to be 0. So VI equals 0 meters per second from a rooftop that is 19.6 meters high. Now, that's a distance. All right, so x equals 19.6 meters. How long? How long is something? That's time. How long does it take, right? I'm trying to find the time of when it dropped. So t equals question mark. Don't forget, anytime you're in the vertical direction, a is always going to be negative 9.8 meters per second squared. And that's all you're given there. So then you're going to say, well, if I have an x in my formula, I have to look at this one down here. So x equals xi plus vit plus 1/2 at squared. Remember, this part's always going to be 0 in our case, so we can cancel that out. Vi is 0, so we can cancel that out. Now we've shortened our formula to just that x equals 1/2 at squared. So x, we know this time, is 19.6 meters, 1/2 negative 9.8 t squared. Now, this is really important. Anytime, even though it says it's 19.6 meters high, that you're actually dropping it from the top down. So you need to make this 19.6 meters a negative 19.6 meters. That's going to be really important when you're doing the math in this problem, because you're going to have to take the square root, and you cannot take the square root of a negative number. So you need this portion right here to be the negative, because when you have this negative, then it becomes a positive as you take the square root. So the first thing I'm going to do is take 1/2 of 9.8. So 0.5 times 9.8 is 4.9. So this is negative 4.9. Bring everything else down. Then I'm going to divide by 4.9. Whoa. 9. Cancels here. So that's negative 19.6 divided by negative 4.9 to get 4. And that's t squared. Well, to get rid of a squared, you have to take the square root of both sides. So then you get 2. 2 seconds equals t. There you go. That's how long it took. And then it asks, what is the velocity of the ball when it hits the ground? So again, we want to know VF. All right, so we have VF equals VI plus AT. VF, we don't know. VI was 0. Plus negative 9.8. And then the time was 2 seconds that we just solved for. So negative 9.8 times 2 is VF equals negative 19.6 meters per second. That's your velocity. Remember, speed is just that number without the negative, so this answer is going to be 19.6 meters per second. All right, I'm going to stop there for now, and I want you guys to do the next 2 on your own, and then we'll check those in class tomorrow. All right, good luck.